So in the last video, we set up a simple experiment where we are comparing fish length between two ponds. And so we talked about how we're going to sample those ponds. Now let's go into collecting the data from those samples. So here are two ponds, and you'll recall that the question is, are the fish larger in one pond or the other? And our alternate hypothesis is that the fish are different. We think that one of those ponds has larger fish. Again, otherwise, why would we even do the study if we didn't think this was true? But we assume that the fish are not different between the ponds, and that's the null. And so we've taken the sample and we're trying to collect data to decide whether or not we can reject that null. So we got 10 fish from each pond, and we measured the length of each fish in millimeters. And here are the raw data, okay? And so I'm going to get my pen here. And you see we've got 10 fish from pond 1 and 10 fish from pond 2. So, excuse me, look at the raw data here. Pond 1 versus pond 2. And can we reject the null? Do you think the fish are larger in one pond or the other? Well, if we just eyeball the data like we did, it seems to suggest that we can reject the null. The pond 1 fish seem to be much larger than the pond 2 fish, just by looking at the raw numbers. But let's look at a different sample. What if this were the sample? Now, same question. Do we reject the null? Are the fish larger in one pond versus the other? It's not as easy now, is it? It's not as obvious. In the previous example, it was kind of obvious that they were larger in pond 1. Here, it's not so obvious. But this is only a sample of 10 from each. What if we had 20 from each or 100 from each, which would be more typical? Would that make it any easier? No, it would make it harder. You'd have all these numbers, all this raw data that you're eyeballing, that you're scanning, trying to decide which one has the larger fish, and it's not very easy. Eyeballing the data is not very useful here. It won't help us make a decision about the null. What we need to do is summarize and simplify these data so that we can understand them better. So how are we going to do that? So here's that sample again. How would you summarize these samples in order to make comparing them a little bit easier, and then make your decision about the null a little bit easier? Well, we've talked about this in class. We're going to use some descriptive statistics. Descriptive statistics is just what it sounds like. They describe the data. So the first question is, what is the length of the typical fish in each pond? A typical fish, how are we going to decide what the length of a typical fish is? We're not worried about the weird, the occasional really small one, the occasional really big one, but we're worried more about a typical fish. How would you do that? Well, you would probably do some sort of measure of central tendency. And we listed some of these earlier, like the mean, the median, and the mode. We already defined those. Those are going to tell us something about the typical fish. The next question is then, well, how typical is the typical fish? So, for example, if we had a mean length for each pond, we also want to know, well, how many of the fish are actually near that mean length? We want to know something about the spread around that measure of central tendency. And how do we do that? Do you remember? Well, a couple ways that we've done that is the standard deviation and the standard error. Those are going to tell us how the fish are spread around that mean value. And so if that spread is really small, then most fish are the typical fish. Most fish are near that mean length. But if the spread is very large, the standard deviation or the standard error is very large, that's going to suggest that there's a lot more variability in fish length. And the last thing we want to worry about is how representative is that sample? How well does that sample that we took represent the entire population of fish in each pond? And that's going to be determined by the sample size. And of course, larger sample size is going to be more representative of the population than a smaller sample size. But we talked about the reasons why we sample. It's not possible to measure every single fish in both ponds. Well, here are the results from that sample. And you see that the mean length in pond 1 is greater than the mean length in pond 2. And you also see we've got a couple variable measurements of spread, standard deviation and standard error, and you see the sample size is 10 from each. So from these data, we see that the average fish length is larger in pond 1. All right. But can we reject the null? So although the mean was larger in pond 1, are you sure that the fish are actually larger in pond 1? Remember, we didn't count every fish in both ponds. We took a sample, so there's always a chance of error. These means are only based on 10 fish out of each pond. Is it possible that we just accidentally grabbed 10 of the larger fish in pond 1 and 10 of the smaller fish in pond 2? That's possible, right? And so, although these descriptive stats are very useful and help us understand and get a summary of the data that we've collected, we still haven't made much progress toward making a decision about the null. So do we reject the null? We still don't know. We see that the mean of one is bigger than the other, but how sure are we that the fish actually are larger in pond 1? We don't really know. We only base that on 10 fish. Is it possible that it's a mistake, and that in our sample we just happen to get larger fish in pond 1? How can we decide if we should reject the null? Well, what we need to do is we need to take these descriptive stats and we need to summarize them. The descriptive stats summarized the raw data. Now we take those descriptive stats and we need to summarize those even further into something called inferential stats. And so the inferential stats will allow us to make a decision about the null. Should we reject the null or do we fail to reject the null? And that's going to be the topic of the next video. So I'll see you then.